Max Tegmark is professor of physics here at MIT, scientific director of the Foundational Questions Institute, co-founder of the Future of License Institute, head of the Tegmark Lab at MIT, and one of our main authorities on the multiverse. So let's hear about it.
Thank you so much for having me. I have often wondered why it is that many of the ideas I have that I'm most excited about come to me in my sleep or when I'm sort of half asleep at night. And now Patty has explained to me why that is. Thank you. So it's a great, great honor to be here with so many other people who are interested in thinking big, thinking about what lies ahead in our future and how we can make it as awesome as possible. I've been asked to speak about the future of Homo sapiens from an AI perspective. I think I was roped into this because I wrote a book recently about the future of Homo sapiens from an AI perspective. And since I'm also a physics nerd, as you heard, I want you to think really big, cosmically big. This big, because 13.8 billion years after our Big Bang, our universe has woken up, right? From a small blue planet, tiny conscious quark blobs have begun gazing out into our universe and discovering something quite humbling, namely that it's vastly grander than we thought, and as far as we can tell, seems pretty dead. But we've also discovered something truly inspiring, as we heard in the intro here, which is that the technology we're developing has the potential to help life flourish like never before. And not just for the next election cycle, but for billions of years. And not just here on Earth, but throughout much of this amazing cosmos. In terms of Homo sapiens and life, I think of the earliest life on this planet as 1.0. Stuff like bacteria that was really dumb, unable to learn anything during its lifetime. In contrast, I call us Life 2.0 because we can learn, which we in nerdy MIT speak might think of as installing new software into our brains, like language skills, computer language skills, etc. Right? And Life 3.0, which can design not just its software like us, but also its hardware, of course, doesn't exist yet. But perhaps we should already call ourselves Life 2.1 with our artificial knees, pacemakers, and cochlear implants. So let's look more closely at our current and future relation with technology. And the metaphor I want to stick with throughout this is that of rockets. Raise your hand if you actually saw the Apollo 11 moon launch. Oh, that's so awesome. I think this is really inspiring because it showed that when we humans use technology wisely, we can accomplish things that our ancestors could only have dreamt of, right? But there's an even more inspiring journey that we're here to talk about today, which is our collective journey into the future with the technology that we're building. And I'm going to focus particularly on artificial intelligence with a smidgen of physics as well. Now, my friend Jan Tallinn likes to point out that there's this really nice metaphor between rocketry on one hand and tech itself on the other hand. Because to do really inspiring things, it's not enough to make your technology powerful. You also have to figure out how to steer it and where you want to go with it, which connects with what Patty said there about the importance of thinking about ethics and what are we trying to accomplish with this. So let's talk about all three for artificial intelligence: the power, the steering, and the destination. And let's just start with the power of artificial intelligence. What is intelligence anyway? I'm defining intelligence simply as the ability to accomplish goals. The more complex the goals, the more intelligent. And I give this very inclusive definition because I want to include not just biological, but also artificial intelligence. And I want to avoid this silly carbon chauvinism idea that you can only be smart if you're made of meat. Why? Because I think it's exactly the opposite of carbon chauvinism, which has given us this amazing AI revolution. The idea that it's all about, that intelligence itself is all about information processing. It doesn't matter whether the intelligence is processed by a neuron in the brain, or by carbon atoms, or by silicon atoms in your computer, or by some other kind of quark blob. And this simple insight has enabled engineers to continuously just swap out all the atoms against other atoms and totally change the under-the-hood substrate, making our memory 10 to the 15 times better, making our compute power 10 to the 19 times better per dollar. And it's not just the hardware improvements, of course, that have fueled things. Also software improvements, where we've come to realize that there are other ways of processing information other than Python and these sort of traditional ways where the intelligence gets put in by a human who's already smart, and the machine instead learns in various ways. Putting the hardware progress and the software together, it's amazing how far we've come, right? Not long ago, robots couldn't walk. Now they can do backflips. Not long ago, we didn't have self-driving cars. Now we have self-flying rockets. Not long ago, we couldn't do face recognition with AI. Now AI can generate fake faces, and it can simulate the faces of each of our speakers saying stuff that they never said. Not long ago, AI could not save lives. Soon it will be able to save very many. We lose over 1 million lives per year on the roads across the planet each year, and most of those can soon be prevented by self-driving vehicles, and that's just the tip of the iceberg. We lose way more lives to pointless errors in healthcare that can be easily avoided, and if we start deploying AI to instead accelerate medical science itself, we can do still spectacularly better, and I'm very much looking forward to the upcoming lectures later here today to hear more about that. In terms of diagnosis, for example, we already have AI systems that are better or as good as human physicians at diagnosing prostate cancer, lung cancer, blindness causing diseases. And finally, not long ago, AI could not beat us at the game of Go. Raise your hand if you've played Go. It wasn't long ago that I was told it was going to be more than 20 years by some of my AI colleagues. And now, of course, it's happened. Google DeepMind's AlphaZero AI took 3,000 years of human Go wisdom, Go games, put it all in the trash, and became the world's best Go player by just playing against itself for 24 hours. And the most impressive thing here is not that AlphaZero crushed human gamers, but that it crushed human AI researchers who had spent decades trying to handcraft Go-playing software. And the same AlphaZero also crushed human AI researchers in chess, which we had been working on since 1950. So all this amazing recent AI progress obviously begs the question for us, how far is this going to go? I like to think about this question in terms of this abstract landscape of tasks, which is really the single most important slide I'm showing you today, where the elevation shows how difficult each task is to do for a machine at human level, and the sea level represents what AI can do today. AI progress is obviously causing the sea level to rise, so we got a global warming going on here in the task landscape, and it's good to be in Massachusetts where I can talk about global warming without being booed. And so one obvious takeaway is raise your hand if you're a student. Yeah, be a little bit careful with going for careers right at the waterfront. But the bigger question is, how high is the water going to end up rising eventually? Is it eventually going to submerge all land, matching human ability at all tasks? This is the definition of artificial general intelligence, AGI. And by this definition, the people who say, nah, there'll always be jobs that humans can do better than machines, are simply saying we will never have AGI. We will never get AGI. Now, if you think AGI sounds like crazy science fiction, then you're probably decided not to go to this event tonight. But in case you're here anyway, I want to remind you that there is something else which sounds like even more crazy science fiction by a lot, and that's superintelligence. The idea is very simple, namely that if we get to AGI, but then since by definition it's better than us at all jobs, that includes the job of AI development, which means that further AI development can now happen on a much faster timescale than the typical human R&D timescale of years. So it opens a very controversial possibility that we could get recursively self-improving AI that rapidly leaves human intelligence far, far behind in a so-called intelligence explosion, creating superintelligence. And we'll get back to that in a bit. But first, we need a little reality check. I'm often told that only philosophers talk about superintelligence, and other people who are just totally clueless tree huggers and don't understand anything about AI. Is that true? Well, I'm going to let you judge for yourself by listening into this little panel that I moderated recently at a conference in California. So before I asked if superintelligence is possible at all, according to the laws of physics, now I'm asking, will it actually happen? Yes, no, or it's complicated?
A little bit complicated, but yes.
Yes, and if it doesn't, something terrible has happened to prevent it.
Yes. Probably.
Yes. Yes.
Yes.
Yes.
No.
So we can settle this issue by just asking a simpler question. Are these people all philosophers? Well, Nick is a philosopher, for sure. But some of them are certainly not. This is Demis Hassabis, right, founder of Google DeepMind, that gave us AlphaZero. And there are a lot of other familiar faces here, including a bunch of very famous AI professors. So no, it's not just philosophers. There are a lot of people who, with technology, what can possibly go wrong? There are a lot of people who know a lot about AI who take superintelligence seriously, so we should too. Does that mean it's going to happen? No. Does it mean that it's going to happen really soon? No. Does it mean we have to freak out? No. But it means we should take it seriously as a possibility and discuss it. So let's do that. First of all, how soon will it happen? Or let's lower the bar and say, how soon will we get to artificial general intelligence that can do everything we can? Here, this is a very genuine scientific controversy, frankly, where you have very serious people on both sides. My former MIT colleague, Rodney Brooks, says, nah, won't happen for hundreds of years. Whereas Demis Hassabis says, oh, he's much more optimistic, and his whole company is founded on building AGI and doing it relatively soon, right? And recent surveys have actually shown that most AI researchers share Demis's optimism, guessing that we are going to get AGI within decades. So within the lifetime of the vast majority of you, because I think you look pretty healthy all in lot, and like you go to the gym, and maybe David Sinclair can give you a few more tips for supplements after this. So, you know, this is very likely, quite likely to happen in our lifetime. And it begs the question, and then what? What do we want it to mean to be humans? To be human if machines can do everything better and cheaper than us? I think it's too common for people to just focus discussions like this on asking what will happen, as if we are some kind of pathetic passive bystanders just waiting for the future to happen to us. No, we are creating this future. And I don't just mean we, almost 8 billion Earthlings, I mean you in this room have a disproportionately large influence over what happens. So we shouldn't just ask what will happen. You should ask yourself, what do you want to happen? So I think we really face a choice here about this question, what happens with AGI? We can either choose to be complacent and just say, nah, let's just make machines that can do everything we can do without worrying about the consequences. After all, if technology makes all humans obsolete, you know, what could possibly go wrong? Or we can be ambitious, which I feel is much more in the spirit of this meeting here, and ask ourselves, really envision a truly inspiring high-tech future that we are on fire about, and then ask, okay, how can we steer towards that? So that brings us to the next part of our rocket metaphor, the steering. We are making AI more powerful, but how can we steer towards a future where it helps humanity flourish rather than flounder? So to help with this, I co-founded the Future Life Institute, and I'm honored to have my co-founder, Erik Tegmark, sitting there in the front row. And our goal is simply for the future of life to exist and be as inspiring as possible, which I don't feel should be a controversial Republican versus Democrat issue. I love technology, of course, and I am optimistic that we can create a truly inspiring high-tech future if, and this is the key, if we win the wisdom race. The race between the growing power of the technology and the wisdom with which we manage it. The challenge to winning this wisdom race is that we've long adopted a strategy for winning it, which worked and has to be changed now, namely learning from mistakes. First, we invented fire, screwed up a bunch of times, then invented the fire extinguisher. Right? First, we invented the car, screwed up a bunch of times, and then we invented the seatbelt and the airbag and laws against driving too fast. And it, all in all, worked pretty good, which has lulled us into sort of a false sense of security. But think about it. Science keeps getting more powerful, and so does technology. And at some point, the technology will cross the threshold of power beyond which you just don't want to learn from mistakes anymore. It becomes a lousy strategy. You don't want to be like, OK, oopsie, we had a little nuclear war now between the US and Russia, and in 30 minutes, we will be continuing our conversation inside of a mushroom cloud. Let's just, oopsie, you know, let's learn from this mistake, be a little more careful next time. Much better strategy is to be proactive rather than reactive, right? Plan ahead and get things right the first time. And that applies not just to nukes, but to a lot of cool stuff you can do with synthetic biology that we'll hear about from George Church, and obviously things we can do with AGI. It is funny, though, because I saw a lot of you nodding when I said this. Might seem obvious to you, but people often tell me, shh, Max, don't talk like that. That's Luddite scaremongering. But it's not scaremongering. It's what we here at MIT call safety engineering, right? Before NASA put astronauts on this rocket, they systematically thought through everything that could go wrong when you put people on top of explosive fuel tanks and launch them to a place where no one can help them. Was that scaremongering? No. That was precisely the safety engineering that ensured the success of the mission. And that's exactly the strategy I think we should all take if we ever decide to build artificial general intelligence, as well as with all the other cool technologies we're going to hear about later today. So in that spirit, we've organized conferences bringing together leading AI researchers and other thinkers to develop this wisdom we need to do the safety engineering right. An output of a recent conference we had are the 23 Calimar Principles, which have been signed by over 1,000 AI researchers around the world and were recently endorsed by the state of California. And I'm just going to tell you very, very briefly about 3 of them. One of them is that we should avoid an arms race in lethal autonomous weapons. The idea is very simple. Any tech can be used for new ways of helping people or new ways of harming people, of course. And like biology is much more likely today to be used for new cures than for bioweapons. Chemistry is much more likely to be used for new materials than chemical weapons. And in the same way, AI researchers really want their technology to be used for accelerating scientific research and do all sorts of awesome stuff, not for building slaughter bots. And it's going to be really interesting to see if the AI community can persuade the decision makers of the world to get to have an international treaty drawing a line in the sand there, just like the biologists managed to get bioweapons banned, so we can keep AI being really a force for good. As I said, with technology, what could possibly go wrong? Another principle there was very broad agreement about was that if we can use AI to dramatically grow the overall economic pie of the planet, and we still can't figure out how to share this enormous wealth so everyone gets better off, right, then shame on us, I think. A third one is that we need to invest a lot more in AI safety research. Research focused not just on making the AI more powerful, but secure and robust. I'm not going to dwell much more on this because I want to cut to a little bit of physicsy stuff in the futuristic spirit here and get to the last part of our rocket metaphor. So we're making AI more powerful. We're trying to figure out how to steer it. But where do we want to go with it? What kind of future do we want to make with our technology? This really is the elephant in the room that almost nobody talks about. And when we talk about it, we usually talk about stuff that might happen during the next 10 years, not during our lifetime. We did a poll recently, and from these roughly 15,000 people asked, you can see most of them actually want us to build not just AGI, but actually superintelligence. It's way smarter than us. And the vast majority want us to be really ambitious and help life spread into the cosmos. And this is something I have to say as a physicist might turn out to be much easier than we thought, thanks to AI. We used to think we had to invent everything ourselves. We don't. We heard in the introduction already how inspiring it's been to just realize, you can turn down the volume here quite a lot, that there's just so much more opportunity out there than we thought. when people walked the earth here over 2,000 years ago, Eratosthenes blew them away by figuring out how big this spinning ball was in space. And they still had no clue about these little white dots in the sky. And they were so underestimating, not just the vastness of it all, but underestimating our own potential. They thought they could make myths about what those dots in the sky were, but that they would never really, really know, right? But the power of the human mind turned out to be much, much greater than they dreamt of. And here we have already succeeded now in doing things like the Sloan Digital Sky Survey that I've worked a lot on to make the biggest 3D galaxy map of our cosmos, where every little dot is a galaxy with hundreds of billions of stars in it. And so the first underestimation we realized was that there's just much more opportunity out there. And the second one was that we would somehow either never be able to get there because we're a meat bag, you know, who wants to be a meat bag frozen in a spaceship for millions of years? Sounds kind of boring, right? And moreover, inventing this technology will probably take much longer than a lifetime. But with artificial intelligence, once you build artificial general intelligence, you can, of course, use it to greatly accelerate the progress of science and bring what felt like a very distant future much more within reach. So, for example, even without AI, we can think big. Robert Forward and many other thinkers have envisioned all sorts of cool things we could do in space. Even in our solar system, you know, we could start by building these habitats which orbit the sun. These are only about 20 kilometers in size. They rotate, so you get nice gravity as usual, and you have a nice system, so you actually get 24-hour solar cycle. Might be a little unfamiliar at first when you look up and see another city up there, but plenty of space and cool. This is not particularly high tech if you have AI-powered technology to build it for you. If you want to go to another solar system, you might think, well, going to Proxima Centaurus, 3 light years, if you can't even get anywhere near the speed of light, you know, you want to, how do you even do it? Well, here's a very elegant solution from Robert Forward. Laser sails. You build a very powerful laser orbiting the sun that just pushes with photon pressure the spacecraft up until it gets to some comfortable fraction of the speed of light. You might wonder, well, how do you stop when you get there then? This is like a car with no brakes. But he came up with this really clever solution where the outer part of the laser sail detaches. So the laser from our solar system pushes here, and then it reflects back on a smaller sail that's attached to your to you. And you comfortably come in for a landing. He figured you can do this in about a 30, 40-year trip to the nearest solar system. If you take some of the supplements that David Sinclair is going to recommend, many of you can totally do that. And if you want to go farther, well, Andromeda, that's 3 million years. Even with resveratrol, you're probably not going to make it to Andromeda unless you're frozen. But that's such an outmoded way of thinking. You are not your quarks, right? Your quarks get replaced, a large fraction of them, quite regularly. We eat, we go to the bathroom. You don't feel emotionally attached to your quarks. It's the information that really makes you who you are, right? Your knowledge, your personality, the way you react to things, your skills. And that can be easily sent very large distances once we figure out more about how the brain works. Your DNA itself is only a couple of gigabytes. So if you're satisfied with having a baby growing up with a clone of you, you can put a lot of babies on one of these little cards or email it and have it raised by robots. If you actually want to send yourself, well, it's maybe 100 terabytes is the total information content of your mind. I suspect you can compress it a lot, but even if you can't, 100 of these, it's not so infeasible. And in the final minute, I want to just stress that basically all the limits all our current technology sucks badly, you know, compared to what's obviously possible according to physics. Fusion reactions, we haven't even made fusion reactors, but they're only 0.7% efficient. You can ask me in the Q&A how maybe you can get to 90% with svalerizers or 42% with a black hole power generator. And So think big. That's what I really want to leave you with. There are so many possible futures we can talk about, and awesome things we can do if we just steer our technology so it doesn't overpower us, but empowers us. And most importantly of all, I want you, when you look up in the sky next time and see those stars out there, to not feel small and powerless like I first felt when I started to realize the vastness of the cosmos. But instead, feel empowered. Because, first of all, the fact that there's just much more opportunity out there, both in terms of space and resources and in terms of time, right? That's a great thing. If you woke up and realized that the entire world was Cambridge, Massachusetts, and there was nothing out it, that would be more disempowering. And second, if you do feel a tinge of insignificance, it's because you feel that you're so much smaller than the cosmos. Right? But your brain is currently the single most complex entity we've found in the cosmos. It's not size that matters, right? What we do, contrary-wise, what we do with our brains on this planet is quite likely to shape the entire future of our cosmos. I mentioned at the beginning that it looks kind of dead out there, and I don't think we live in some sort of Star Trek world where they're all hiding from us. Life so far is just a tiny perturbation on what's happening. It doesn't have to be that way. Life went on Earth from being a tiny perturbation to completely dominating our planet. And it's very likely, if we don't screw up with our tech, that one day much of our cosmos is going to be teeming with life. Totally dominating what's happening. Our universe will have woken up so much more than it has now, really becoming aware of itself. And it will probably be because of what we humans do on our little planet in our lifetime. And people from MIT like you will probably have a major part in making this decision, whether we're ultimately going to use all our technology to just blow ourselves up or go extinct by some stupid, sloppy mishap, or create a truly, truly inspiring future for Homo sapiens and life beyond. So let's make a difference.
Maybe one or two quick questions, but before I take one from here, you got to tell me what a spherizer is.
A spherizer. All right, yeah. So basically a more fancy diesel engine. A diesel engine, as some of you know, has no spark plugs. You just take this mixture of diesel oil and oxygen, air, squeeze it together, and when it gets hot enough, it combusts, and then when the piston goes out again, there's just more energy there than there was before. Turns out, we know now from particle physics that if you can squeeze things much, much, much more together, you take just a bunch of random matter, it can be your household trash for that matter, and squeeze it together to extremely high temperatures. When it comes back out again, E equals mc squared, about 90% of that will have been turned into energy. In contrast, the sun, when it does fusion and turns hydrogen into helium, 0.7% only get turned into it. Basically, on this planet and in your household trash, there's way more of the energy is in quarks and electrons than it is in photons. Once you squeeze it really, really hard and pull it back out again, it's about the same number of photons as quarks. Pretty nice trick.
You go through neutronium into photons.
So think big.
Yeah, that's great. One question from the web. With the decline of Moore's law, will the decline of Moore's law prevent or stall the development of AGI?
No. I can elaborate a little bit also. I think the decline of Moore's law is really lame and overhyped. Moore's law refers very to a specific paradigm of computing, shuffling electrons around in 2 dimensions on chips, right? Yeah, of course that's going to fizzle out, just like punch cards kind of plateaued also. So you switch to a new paradigm. Right now, for example, my colleague here in the MIT physics department, Martin Soljacic, is building a really cool new chip which computes with photons rather than electrons. Forget about Moore's law. There's so many more great breakthroughs one can do if we just think a little bit out of that box of that paradigm. Moreover, for AGI, I might be in a minority here, but I actually feel that we already have the hardware today sufficient for making AGI. We're totally limited by software. We're just not being so far from understanding the software that's needed.
That's what Marvin Minsky said in the 60s, but we're in a different time now. I think power-wise, there could be an issue.
Yeah,
In the panel, we can talk about this and so much more. Anyway, let's thank Max again.